This next video will be covering the 3 methods of charging that you need to understand for the AP Physics 1 exam. So up until now we've talked about objects that are charged, that have already received a charge, that already have a net charge. Here we're going to talk about ways to give things a net charge. The first method is called charging by friction. This is how you end up getting an electric charge on yourself when you go to shock yourself on a door handle or something like that. When 2 materials are rubbed together, so by rubbing 2 materials together, one will remove electrons off of the other, resulting in positive and negative objects. Our example of this is static electricity. All of these methods of charges have to follow the law of conservation of mass. Specifically, we're going to be focused on what we call the law of conservation of charge, which is kind of a corollary of the law of conservation of mass. If my 2 objects together have 0 charge to begin with, and I manage to rub them together, and one of them gains electrons, the other one will have lost that number of electrons. So that if I started with a net 0 charge between my 2 objects, I still have to have a net 0 charge. If I started with a positive charge, I'm going to end with a positive charge. My total charge cannot change. The second is charging by conduction. This requires that our objects are conductors. There are 2 kinds of objects out there. There are conductors, which allow charge to move easily, typically metals, and then there are insulators, which do not allow charges to move easily. Things like rubber or wood tend to be pretty good insulators. Plastic is a good insulator. Now, there's a fuzzy line between what is considered a conductor and what is considered an insulator, and that line can break down. What was an insulator can become a conductor if it breaks down. For instance, air is a very, 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 very good insulator, except when there's enough charge buildup on the ground or in a cloud, and then you get a lightning strike and there's electrical conductivity there. So just because something is a conductor doesn't mean it's the best conductor. Just because something is an insulator doesn't mean it's the best insulator. Anyways, back to charging by conduction. By touching a charged conductor to another conductor, the charges will distribute between the objects. Note, if the objects are identical, that means they're the same shape and size, the charge distribution will be even. So if I have object A is positive 2 coulombs, object B is negative 4 coulombs, my net charge is negative 2 coulombs. After I bring them in contact with each other, negatives will flow off of the negative 4 and onto the positive 2, and we will end up with a negative 1 coulomb charge and another negative 1 coulomb charge, assuming that these 2 objects are evenly shaped and evenly sized, which they're going to be for the extent that we need to get to. our net charge is still negative 2 coulombs. The third method of charging is the most complicated. It's called charging by induction. It requires a conductor. Specifically, it requires that the thing you are charging is a conductor. With both charging by conduction and charging by induction, we have things that are already charged. Charging by conduction, we could have one thing already charged, we could have two things already charged. Charging by induction, we're typically going to have one already charged object and one object we are trying to charge. The object we are trying to charge must be a conductor. The object that is already charged could be an insulator. Doesn't really matter. Charging by induction operates on the principle of polarization. By bringing a charged object near a conductor, not touching the conductor, but just bringing it near, the conductor will polarize. To polarize an object, I'm going to go ahead and skip down to the drawing. Here we have our positively charged object. It could be a conductor, it could be an insulator, it doesn't matter. And here we have the neutrally charged object that we are trying to charge. By bringing this positively charged object nearby, we are causing the charges inside of our conductor here to polarize. The negative charges are going to get pulled to the right because opposites attract. And the positive charges inside the sphere are going to get pushed to the left because likes repel. This object here is now polarized. It is not charged because the net charge on it is still 0. I have 3 positives, 3 negatives, that equals 0. But the charges are separated so that one region acts positive and one region acts negative. Now, if these two objects were just hanging out nearby, they would attract to each other because positives and negatives attract. But that's something we're not going to worry about right now. If the charges that are repelled are given an escape route, there are two methods of giving this charge an escape route. I could touch another object over here, or I could do what is called grounding. So grounding means connecting a wire to the ground, and our symbol for grounding looks like this. The ground acts as a storehouse or a sea for extra charges. We can put a whole bunch of charges into it, we can take a whole bunch of charges out of it. Now these positive charges have a way to run. They're still trying to repel from our positively charged object on the right, so they're going to run down the wire into the ground, and they're going to not be on the object anymore, which means my object is now negatively charged. But it's only temporarily negatively charged. If I remove this object here, those charges are just going to run right back up and balance out. So in order to leave behind a permanently charged object, and the escape route is removed. So if I take this wire that has allowed my positives to run away and I cut it, the positives cannot come back. It will leave behind a permanently charged object. The conductor will retain a charge. So these are our 3 methods of charging. On this topic, we could also kind of go off on a tangent and talk about how to know if something is charged. If I have a mystery object, and I bring a positively charged object nearby, and it attracts, that means my mystery object, there are three options. Could be positive, could be negative, could be neutral. If it attracts, that means it's not positive. It could be negative. If it were neutral, it would have polarized, meaning there are negative charges nearby to attract. So attracting an object that is of unknown charge would mean that it's either oppositely charged or neutrally charged. If I then bring a negatively charged object nearby, and it also attracts, it means that it cannot be negative, because negative would have repelled, and it must be neutral. So, a positively charged mystery object would repel from positive, a negatively charged mystery object would repel from negative, and a neutrally charged mystery object would attract to both. So those are the three different methods of charging. They tend to show up in pretty simple questions. Charging by conduction tends to be a pretty simple question. Charging by induction, I've seen that show up as a pick two multiple choice question before. So knowing these three different ways of charging objects is important.